What
We
did we
started.
finish?
We started real numbers.
We were doing real numbers, right, in the previous
Yeah.
class. So with real numbers, we started with the first exercise, and the first exercise was we studied the arithmetic law of real numbers for all the mathematical numbers. What was that? Can you just give me an overview?
Law of arithmetic. It means that every composite number has a a unique set of prime numbers apart from the order of the prime numbers which occur.
Yes. And then what are composite numbers and what are prime numbers?
Composite numbers are numbers which has more than two prime numbers, and prime numbers are numbers which has its one and its own number as its prime numbers.
Okay. Then we studied finding the LCM and the HCF. So how are we finding the LCM?
LCM. So the numbers in the if you take two numbers and prime factorize it, the highest exponent of all the numbers in the factorization is LCM, and the lowest exponent of all the common numbers is HCF.
Yeah, we used to do like that. Good. So today we shall be moving ahead. Just give me 1 minute.
Sure.
Okay. Now, what we study in real numbers is basically the next thing that we come across. We practiced your question. Did you do your assignment question where?
Yes, ma'am.
Any doubts in your assignment question? We can discuss it. The question that I gave you was finding the LCM of 17, 23, and 29. Now, I taught you in the previous class also that there are three ways of finding the LCM. Did I teach you this? I did not teach you. Wait, there is one more point to discuss. Note point. There are three ways of finding an LCM.
Yeah.
Now, when we have two numbers which are divisible by one another, that means they comes in the table of each other. For example, you have 2 and 8. So 2 and 8, they come in the table of each other, right? So the greater number is always the LCM. So here, what is the LCM? It's 8. For example, you have 4 and 64. 4 and 64 are divisible by one another. So what is the LCM? LCM is the greater number, which is 64. Alright. Now, if there are this is the first way of finding the LCM. If you have two numbers which are divisible by one another, two or more than two numbers, then always the greater number is the LCM. Now, the second way of finding the LCM is when we have numbers which are not divisible completely, but they have a common factor with them. For example, you have 2, or let's call it 4 and 18. See, 18 does not come in the table of 4. But 4 and 18 have a common factor. What is the common factor for 4 and 18?
Two.
What is the common factor?
Two.
2 is a common factor. So 4 and 18 have a common factor, which is 2. So for the numbers which have a common factor between them, what do we do? We find the LCM by prime factorization. Okay, so we will do all this method. So the LCM will be 4 into 9, LCM will be 36. Now the third way of finding the LCM is when we have two numbers which does not have a common factor and they are not even divisible. For example, 2 and 13. 2 and and 13 are not divisible. They do not even have a common factor. So how do you find the LCM? You just multiply such numbers. So what is your LCM? 26. Understood?
Yes.
This is how we find the LCM. For example, you have 17 and 13. So 17 and 13, the LCM will be 17 into 13.
This is if both the numbers are prime numbers.
Speak a little loudly, Umair.
Is this if the numbers are prime numbers or
Yeah, if the numbers are prime numbers, see, both the prime numbers, obviously, they are not going to have any common factor between them. Right? So if the numbers are prime numbers, that is only the case when they're not going to have a common factor between them. Also, they're not going to have um, any common factor, or they're not even divisible. Then only they are prime numbers. So for prime numbers, how do we find the LCM? If all the given numbers are prime numbers, you just multiply those numbers and find the LCM. If the given numbers have a common factor, then you what you do? You do the prime factorization method. And finally, if you have numbers which are divisible by one another, then what you do? The greater number is the LCM. Will you remember this thing, Umair? Okay. So now see, now this thing you do not have to really show in your notebook. This is a trick that you should remember. Okay. So you do not show this thing in your notebook. In your notebook, you're going to show that method only which we discussed yesterday. But this is like for quick answers. For example, now the question is 17, 23 and 29. Now you clearly know all these numbers are what kind of numbers? Are they composite or prime?
prime?
They're prime numbers. So how will you find the LCM? You will just multiply 17 into 23 into 29. Right? So this was your homework question. Next we come to the next one. Question 4. What does question 4 say now? It says given the HCF of 306 and 657 is 9, find the LCM of 306 and 657. Okay, now we studied one formula. What was that formula? That if you have two numbers, then the HCF of those two numbers multiplied by the LCM is equals to the product of those two numbers. This was the formula. You remember this? So the HCF of 306 and 657 multiplied by the LCM is equals to 306 into 657. What is the LCF? 9. What is the LCM? We don't know. And you just multiply 306 into 657. Okay, then LCM will be equal to, you can cancel this, 306 into 657 divided by 9. 34 into 657. Okay, you multiply these numbers and you get your LCM. Whatever answer you get, that will be your LCM. Alright, Amit? So fourth question is also very easy. Then what is the fifth question? It says that check whether 6 to the power n can end with the digit 0 for any natural number n. Okay, so checking if the given number ends with the power of ends with 0 or not. So we have a certain example also in this exercise only, which is example 1, which says consider the number 4 to the power n. So 4 to the power n is any number. Let's suppose 16. So 16 is 4 to the power 2, right? 64. 64 is 4 to the power 4, right? So let's consider any number 4 to the power n. Now n can be any integer. Then what are they asking you? N is a natural number, okay? Both check whether there is any value of n for which 4 to the power n ends with the digit 0. Okay. So what do we have to do? We have to check whether 4 to the power n, like 4 to the power 5, 4 to the power 6, 7, 10, 11, 20, any 4 to the power can end with the digit 0 or not. Do you understand the question? I'm saying no.
Yes, ma'am.
I'm not asking you no for the question. What do you think about the answer? Can it end with 0 or not? Can it
You
end with
want
0? One
you
second,
want
okay? Well, please just hold on for 1 minute. Okay, Umair, do you hear me?
Yes, ma'am, I hear you.
Okay. So now 4 to the power n, they're asking you if they can end with 0 or not. Now tell me one thing, Umair, do we know that any number that ends with 0 has a factor 5? For example, 10 ends with 0. So it has a factor 5, right? We have 100. It also has a factor 5. We have 1000. We have 150. We have 250. We have 3750. Any number that ends with 0 has a factor 5. You know this thing, right? Now tell me one thing. 4 to the power n. So we need to check, does 4 to the power n has a factor 5 or not? So we know that 4 to the power n, let's break it down. 4 to the power n is written as 2 to the power 2 and whole power n. So it becomes 2 to the power 2n. See, 4 is written as 2 square. So 4 to the power n is written as 2 square to the power n. So 2 to the power 2n. You understand this step or not? Yes or no, Mayor? You don't understand it. Okay, no problem. Okay, tell me
Whole
one thing.
in a different way.
Okay,
That's
you
what I.
understand? Did you understand one thing? The question, what is the question? They are asking you, can 4 any power of 4, any exponent of 4, can it end with 0? For example, 4 to the power 5. Can it end with 0? 4 to the power 20, 4 to the power 100. Can any power that you put on 4, can the number end with 0 or not? That is the question they are asking. You understand the question first? Okay. Now tell me one thing. We know that all the numbers that end with 0, they have a factor 5, right?
Yeah.
All the numbers that end with 0 has what factor? They have a factor 5. That means 4 to the power n should also have a factor 5 if it has to end with 0. You understand this? Yes or no? Tell me clearly. Okay. So now let's check whether 4 to the power n can have a factor 5 or not. So when I break down 4, how do I break down 4? 4 is written as 2 into 2, or I can say 2 to the power 2,
Yes.
2 square. So 4 is equals to 2 square. So 4 to the power n is equals to 2 square to the power n. 4 is equals to 2 square. So 4 to the power n, when I put the power n over here, I also have to put a power on the right hand side. So 4 to the power n is equals to 2 square to the power n. Is this clear? So 4 to the power n is equals to 2 to the power 2n. That means I can write 4 to the power n as 2 to the power 2n. Now tell me, is it clear or not? Can I write it like this or not? Try to understand it. Right? I can write it like this. Now, with this step, what do I get to know? That all the factors of 4 to the power n only will have 2 as their factor. That means,
Yes.
like whatever 4 to the power n is, for example, it's 16, 32, 64, any 4 number, okay, it will have only 2 as its factors. Like 2 into 2 into 2 into 2 into 2 into 2 and so on. It will not have any other number as its factor. Okay?
Yes.
So that means 4 to the power n does not have 5 as its factor. 5 is not a factor. Now tell me, if 5 cannot be a factor of this specific number, that means this number is not ending with 0. Because if it was ending with 0, then 5 would have been a factor. You understand it? I'll explain you once again. Look here. What is the question? Now you are going to explain. Tell me what was the question. Tell me, ma'am, what is the question?
So the question was, they said that four n, where n is a any real number.
No, it's not 4n. 4n is different and 4 to the power n is different.
4 to the power n with any n as any real number. Can it end with the digit 0?
Yeah,
So
can it end with
for,
0 or not? Yeah. So,
so for any number to end with the digit 0, it should have 2 and 5 as its prime factors.
no, not 2 and 5. It should have only 5. 2 can be or cannot be, but 5 has to be. It's not really necessary that it will have 2 as its factor. Okay, it will have 2 as its factor also, but specifically we are talking about 5 here.
The textbook has 2 and 5.
What are you saying?
The
Ma'am,
textbook there.
first of all, please increase the volume of your system.
Yeah, I'm talking low. In the textbook, they had put 2 into 5 should be there, and cause 5 is not there in this number, so this number will never end with the number prime with the digit 0.
Yeah, that is correct. So do you understand the solution or not?
Yes, I understand.
Okay, any doubts in the solution? Any doubts do you have in the solution? No. Okay. So we move ahead now. We have question 6. Question 6 says, no, I explained you the example. So it is 6 to the power n. Okay, now again, 6 to the power n. They are asking you whether it can end with 0 or not. Now we studied that the numbers that end with 0 should have 5 as its factor mainly. Okay, 2 also. So 2 and 5 as its factor. So 6 to the power n. First of all, let's try to break down 6. So 6 can be written as 2 into 3. So 6 to the power n is written as 2 to the power n into 3 to the power n. Right? So that means 6 to the power n is not going to have 5 as its factor. Right? That means 6 to the power n cannot end with 0. Understood? So no, it can't end with 0. Next is question 6. They're asking you explain why 7 into 11 into 13 plus 13 and okay, this you can leave for now. Circle path of field. Sonia takes 18 minutes to drive one round. Okay, this is a very good question. Let's do question number 7 first. So what is question number 7 telling you? It says that there are two people, Sonia and Ravi. So, and there is a circular round. Okay, so this is a circular round. So Sonia takes how many minutes to complete this one circular round? Sonia takes 18 minutes. And how many rounds does Ravi take? 12 minutes. So now they are asking you, they start at the same point and at the same time and go in the same direction. After how many minutes are they going to meet? So tell me, what are you going to do in this question?
I will find
You will do,
LC.
speak again, okay?
LCD.
LCM you will do. Okay, so try finding their LCM and tell me the answer.
LCM is 2 square into 3 square, 0.9. LCM is 36.
LCM is 36. That means after how many minutes are they going to meet? Like
It's
Sonia took one round 18. So like Sonia took one round in 18 minutes, another round in 36 minutes. Ravi will take one round in 12 minutes, another round in 12 minutes, and the third round. So when it will be Sonia's second round, it will be Ravi's third round. Okay, and they are going to meet at that point. So they will meet
yes.
after 36 minutes. Okay, you understand this question? Then we have understood this question. Shall I move ahead? Umair, shall I move ahead? Do you hear me? Umair, do you hear me? Umair, do you hear me?
Yes, ma'am.
Okay, we have one more question. The question is, one second. So it is given, determine why the given expressions are composite numbers. And what are the given expressions? 7 into 11 into 13 plus 13. So this is the first number. And 7 into 6 into 5 into 4 into 3, 2 into 1 plus 5. This is the second number. So you have to prove whether they are composite numbers or not. Okay. So first of all, what are composite numbers?
Composite numbers are numbers which have more than two prime factors.
Umair, speak loudly. I can't hear you.
Composite numbers are numbers which has more than two factors.
More than two factors. Okay. So they have more than two factors. Right. And so basically, if you prove, see, what should be your approach? They're asking you prove that they're composite numbers. So, and we studied what are composite numbers. Composite numbers basically should have more than two factors. So, if you prove that these numbers are more than two factors, can I say that they are composite numbers?
Yes, ma'am.
Yeah. So, how am I going to prove that they are composite or not? Like the first one.
The,
This is the first one. It is 7 into 11 into 13 plus 13
yeah,
only. Okay. Now, if I prove that this number has more than one factor, I can say it is a composite number. Now, how to prove? Basically, can I take 13 as common? So, what is left? 7 into 11 plus
this one.
1 is left inside the bracket. So, that means I get to know the factors of this number are 13 and this number,
Seven, seven, eight, seven.
right? So, that means it has two factors, right? And similarly, if I solve the second one, what is the second one? The second one is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Okay, again, what do? I take 5 as the LCM, 5 is common, and then I'm left with 7 into 6 into 4 into 3 into 2 into 1 plus 1. So again, I have two factors, 5 and this number, right? So that means they're composite number. Now either you can leave your question here only, you can just write, explain properly. That since the numbers are more than two factors, more than one factor, see, because obviously one will be a factor, then 13 and then this number. So it has more than two factors. Again, for this number, one will be the factor, 5 and this number. So it has three factors. Both of them have three factors. Or you can solve this part also. So this part becomes 7 into 11 is 77 plus 1 is 78. You can say the factors are 1, 13 and 78. Similarly for this what you can do, you can solve inside of the bracket. Multiply this entire thing, 42 into 12 into 2. So 42 into 24.
8, 16.
1008 plus 1. So 1009. We get to know 1, 5 and 1009 are also the factors of the given number. That means they are composite numbers. Understood?
Yes.
Okay. So this is how we will do the first exercise. So any doubts from the first exercise that you have? See, I solved
Ma'am,
the first exercise for you because it was a very simple exercise, very easy questions, but they are also tricky questions. If they are asked in exam, you should know how to properly solve them. You should be able to write all the steps, mention all the steps, and then solve it. Okay? Remember this thing. So So now we come to the next exercise. We have revisiting irrational numbers. We have just two exercises. So you can do one thing, Umair. You can practice first exercise on your own now. Practice all the questions
Like
on your
so
own,
many worksheets.
and then when you're done, then you'll move to the second. What are you saying, Umair?
Real numbers, because we have PS, I did so many worksheets at home.
I don't hear you, Umair. Speak again.
Because we have PS, I finished so many worksheets at home, like 4 or 5 worksheets. Can you hear me?
No, I don't hear you. Your voice, I can hear you, but your voice is very low. I'm not able to understand what you're saying. One second, let's do one thing. Let me try using earphones. Okay, just 1 minute. Okay, Umair, do you hear me?
Yes, I can.
Okay. Try speaking something, please.
Yeah, can you hear me?
Yeah, I do hear you. Now, please tell me what you were saying.
Oh no, I just said that I did so many worksheets at home because we have PS.
You did so many questions in one go, but no, that's another thing. But right now in the class, we did you didn't do anything from the class, so you have to do these questions first. Okay, solve these question once. We already did till third question, so you only have to do question 4, 5, question 6, and question 7. Just practice them once and practice them fairly. Okay, it should not be untidy work because I want to see what you're solving. So after the class, you have to send me a copy of this. All right? Send me a photograph of
Assignment.
this after the. No, not as assignment. Just send it to the team. They will forward it to me. Just click a photograph, send it on WhatsApp only. Okay. So do
Should I
it
take
in
my
a neat and a tidy way.
should I take my textbook?
Yeah. You can bring your textbook, bring a notebook also, and write down all the answers in a proper way. All the steps should be mentioned.
Ma'am, should I write the questions also? Ma'am, should I write the questions too?
No, you don't have to write the question. You can skip the questions if you want.
Thank Ma'am, shall I send it? Ma'am, yes.
Yes, Umair, have you completed?
Yes. I completed.
Okay, Umair. Okay, all the questions.
Should I send it right now?
What are you saying?
Should I send it right now? Shall I send it right now?
No, you don't have to send it right. Now we will move ahead. Did you complete it just now only, or you had completed it before?
I completed it just now.
Okay. Actually, I since I connected headphones to the device, so I wasn't able to hear if you were saying anything. So next we have is irrational numbers. One second. Okay, so Mel, you have any idea about irrational numbers? What are irrational numbers?
Rational numbers are numbers which cannot be written in the form of p or q, where q is equal to 0 and pq, the pq of the x.
Which can be written in the form of P by Q, or which cannot be written in the form of P by Q?
Which cannot be written by the p.
Which cannot be written. So we know that rational numbers are written in the form of P by Q where P is not equal to 0, but irrational numbers, they cannot be written as be written in the form of P by Q. Alright, so we have a few theorems. So first of all, the very important amongst all of them is you have to prove that root 2 is irrational. Okay, prove that root 2 is irrational. So how do you prove that root 2 is irrational? Basically, let's assume that root 2 is rational. Okay, let us assume root 2. Okay, now if root 2 is rational, then root 2 can be written in the form of P by Q. Yes or no? Tell me. Yes or no? Umair?
Yes, ma'am.
Okay. So can I say that root 2 is equal to P by Q? Thus, when I cross multiply, I get Q into root 2 is equals to P. I just cross multiply. And now on squaring both sides. What do I have? Q root 2 square is equals to P square, right? So what is Q root 2 square? 2Q square is equals to P square. You understand this much?
Yeah.
Okay. Now tell me one thing. If 2Q square is equals to P square, that means 2 will divide P, thus
Yes.
2 divides P, right? That means now if 2 is dividing P, can I write P is equals to 2R? See, because P is being divided by 2. For example, if 10 divides 2, you get 5. So can I write 10 as 5 into 2? So if I say 2 divides P, let's suppose P is 10. So 10 is equals to 2 into the 2 into the question. Right? So what is the question? Some number R. So P is equals to 2R. Yes or no?
Yes.
Now, what was the value of p square first of all?
4r square.
How 4r square?
P square is 4r square.
Okay, yeah. P square is equals to 4r square. Right. Now, also we know that p square is equals to 2q square. That means 2q square is equals to 4r square. Can I say q square is equals to 2r square?
Yes.
Right. That means p square and q square have a common factor.
Yes.
So I will write it down. Does 2 divides q square and also q, and hence p and q have a common factor which is 2, right? Now, what was our assumption? Our assumption was that root 2 is a rational number where root 2 can be written in the form of p by q. But we know that p by q, here p should not be equal to 0 and p and q should not have common factors. They should not have any common factor, right? But this,
Yes.
now what we proved, this contradicts the fact, this contradicts the fact that p by q does not have a common factor, and thus hence our assumption was false. And root 2 is irrational. So what did I do in this question? First of all, I assumed that root 2 is rational. Now if it root 2 is irrational, so we know that rational numbers are written in the form of p by q. That means root 2 is equals to p by q. And then what did I do? I proved that p and q have a common factor which is 2. And then I am contradicting the fact that p by q does not have any common factor. And finally I get to the solution that root 2 does not root 2 is irrational. Understood, okay? Alright. So your homework will be that you have to do this entire solution in your notebook and upload it on the portal. Okay, I shall be posting this question on the portal. I'll be posting two questions. One, root 2 is irrational, and one, root 3 is irrational. So write all the steps. No, none of the steps should be missing. Okay, write all the steps for both the questions, root 2 and root 3, and upload it on the portal. And then I shall be checking and uploading it back. Okay. Any doubts you have there?
Ma'am, I learned the same thing, the same method, but with different wordings. It's fine, right?
But with different.
Like the phrases.
Okay, what did you learn? Tell me.
First, before taking the q to the 2, I squared both sides. Then we divide, like, and if I that root 2 is rational, and root 2 is equal to p over q is not equal to 0. CF of pq is equal to 0. So, and in the end, I say that HCF of root 2 is not equal to 0, is not equal to 1. So it contradicts the fact that root 2 is irrational, and our
Did
solution
your
is
school
wrong.
teacher teach you
Because of
this,
that.
Umair? Did your school teacher teach you this?
Yes.
So you can do one thing.
Yes.
That method is also correct, but I need to see have you written proper steps or not. So whatever method you have learned, send it to me on WhatsApp. Okay, send it to the team. They will forward it to me on WhatsApp, and then I will check whether your method is correct or not. And if you like doing that method, we can discuss that method also in the class. Okay. It's
It's
okay.
almost the same thing.
Yeah, I understand. It's entirely the same thing only. What is our motive is to basically prove that P and Q are having common factors. So either you can do it, say it by HCF. HCF means highest common factor, right? So it's the same thing only. But you have to send it to the team. They will forward it to me so that I can check whether your steps are correct or not. You've written the correct phrases or not. Okay.
Okay.
Right. Unless you have any